Okay, here's the demonstration for using the TI-83 calculator for Chapter 3. We're going to do several things here. We're going to calculate some statistics from a set of sample data. We're also going to do it for a frequency distribution and then do a box plot. The sample data that we're going to be using, I'm going to do three different examples. I'm going to be using the data from problem number 5 in your textbook on page 94. That's in section 3-2. I'm also going to be using the data from problem number 29 on page 97 in your textbook. And then finally, we're going to be, for the box plot and 5-number summary, we're going to be using the data from the table 3-4 on page 116 of your text about movie budget. So let's start off. We'll look at just doing a simple mean and standard deviation for a list of data. That uses the data from problem 5 on page 94. So the calculator's here. I've already entered the data, but this particular set of data, problem 5 on page 94 your text, has got the number of words on the pages of a dictionary from a sample of several pages. So when you're going to do something like this with your calculator, first thing you do is put the data into a list. And so you click the Stat button, select the Edit option, and you can see that list L1 up here has got the data from that problem, 51, 63, 36, so on and so forth down the line. Again, when you're working a problem like this for a homework or a test, double check the list after you've entered the data. I've already done this, but double check the list to make sure you've got the data entered right. If you don't, you're going to get the wrong answer and you're going to get the problem wrong. So it's worth taking a few extra seconds to double check the data. So in order to get things like the mean and standard deviation, what I'm going to use is something under the Stat button. So I'm going to click Stat, and I'm going to go to the Calc menu, so I'll right arrow over there, and use the first option on that list, which is called one variable stat. So I'll just hit Enter. Now I need to tell it which list to use. And if you notice, the orange functions above the numbers 1, 2, 3, 4, 5, 6 are L1, L2, L3, L4, L5, and L6. So what those will do, we'll put the name of the list into your entry screen. So I want to tell it to use list 1, so I hit second and the number 1, and it puts list 1. And what I'm telling the calculator to do is do this thing called one variable stats, one var stats, using list 1 for your data. When I hit enter, I get a screen full of data. The only ones I really care about are the X bar, which is 53.3, which is the average for this set of data, or the mean. And that value is calculated the same whether the data happens to have been a sample or whether it happens to come from a population. Notice that I've got two values for standard deviation. I've got a value that says SX right here, and I've got a value that says sigma x here. If you recall from our slides and from the book, the standard deviation for a set of data is calculated differently whether the data is a sample or a population. The calculator doesn't know whether the data that you've got in your list represents the data from a sample or from a population, so it gives you both of those. Only one of those two is correct. And for this particular case, if you go back and read the problem, it's very clear that the data, it says it's from a sample of pages taken from a particular dictionary. And so the standard deviation for this data set is 15.7, okay, rounding to 1 decimal place more than what the data values show. Okay, the data values are all in integers, whole numbers, so I would write down the mean as 53.3, and I would write down the standard deviation as 15.7. This value here, sigma x, 14.9, is not an alternate standard deviation for this data set. It's nothing. It's worthless. It's meaningless for this data set. This data set is not a population, so you would never calculate the standard deviation using the sigma calculation. The only value that applies to this data set is this SX. So you have to know whether that data that's in that list applies to a sample, in which case you use the SX, or it applies to a standard deviation, in which case you use the sigma X. And notice there's a little down arrow over here. N equals 10, by the way, tells us how many data values there were. If you scroll down, I'm going to use the down arrow button over here, click on this a few times, I get another screen full of data. And basically what this is the 5-number summary. Minimum, the first quartile, median, third quartile, and the max. Okay? So that's how you do simple results for a single data set. Now what we want to do is do the same thing, but let's use a frequency table. And the frequency table that I decided to use is from problem number 29 on page 97 of your textbook. And if you look at that data set, the first thing that you have to figure out is what are the midpoints. Our formula for doing the mean and standard deviation for a table of data requires the midpoints. And to figure out what the midpoints are, you just take the two values, like for the first row, 10 and 13, that totals up to 23, you divide by 2 and it's 11.5. The next value, it's 15.5, and they keep going up by 4, okay? And the counts are, or the frequencies for that problem is given in the book, again on page 97, are 1, 0, 15, 7, and 2. So I've entered those values into my list editor. Again, I'll go Stat, Edit, and you'll notice that list 2 has got the midpoints for those 11.5, 15.5, 19.5, 23.5, 27.5. Those are the midpoints for the rows in that problem, and it's got the counts over here in list number 3. So I've got list 2 as my midpoints, list 3 is my frequencies. To do mean and standard deviation from that, I'll use one variable stats again. So I'll go hit the stat button, calc, select one variable stats, but this time I'm going to give it 2 lists. The first list, when you use one variable stats in table mode, the first list has got to be the list that contains your midpoints, or if it's a table of discrete values, the list that contains the actual data values. So the list that contains my midpoints is list 2, and then I got to put a comma in here, that's this button right here, and tell it the second list has got to be the list that has your frequencies in it, okay? And the list with my frequencies in my case is list 3. I hit enter. I see that my average for this set of data values is 20.9, and my standard deviation is, depending on whether it's a sample or population, is 3.24 or 3.18. I would actually round both of those to 3.2 for this particular set of data because the data values were all integers, but it raises the question, is the data in that table a sample or a population? If you read a problem, it's not entirely clear. I would suspect that it's probably a sample. In this class, for homeworks and tests, it's going to be very clear whether the data that we're looking at is a sample or population, and you'll be able to pick the correct standard deviation. For this particular problem, that's not important, and so they didn't mention it, but for this data set, I would probably use the SX value rather than the sigma X value. So to do a box plot and a 5-number summary, the example that I want to use is the set of movie budget data that's on page 116 of your book on table 3.4. And give me a second, I'm just going to flip to that page here while I'm doing this. And if you look on that data, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns. There's 35 data values, and I've already gone in and entered those in my stat editor, stat, edit, and if you go over to list 4 here in my list, these are the 35 data values. And again, I've already double checked those to make sure that they're the correct values. Okay, and there's the 35th value, and there aren't any more. So let's do our one variable stats on those. Again, I go to the stat button, calc menu, one variable stats, tell it to use list 4 this time, and I get my average my standard deviation, and so on and so forth. If you scroll down, again, I'm just hitting the down arrow, I get my 5-number summary. Okay, minimum is 4.5, the Q1 is 35, the median is 68, Q3 is 113, and the maximum is 225. I want to use those to calculate my fences. What's the lower bound and the upper bound for checking for outliers? So my lower fence is always my Q1, which is 35, minus 1.5 times the interquartile range. And the interquartile range is the difference between 113 and 35. So I'm going to do that in parentheses, 113 minus 35, because I want that done first, and I multiply that by 1.5. Okay, so I'm taking the interquartile range, which is 113 minus 35, multiplying it by 1.5, and subtracting that from Q1, which is 35. And I get the lower fence is minus 82. So if any of the movies had a budget of minus 82, or less, it would have been an outlier. Probably not possible to have a budget that low. Okay, you probably can't have a budget less than 0. So there aren't any outliers. I want to calculate the upper fence, which means I need to take 113 and add this 1.5 times the interquartile range to it. So to do that, I'm just going to recall that previous entry. So I'm going to do second enter, which recalls that. I'm going to edit it. And I'm going to change the 35 to 113, 113, and to insert a new character, you got to use the INS function. So I'm going to do second insert, enter 3 in there, and then I need to change this minus sign to a plus sign there, and delete the minus sign. So now there's my calculation for the upper fence. And notice my upper fence is 230, which is pretty close to the maximum value, and the data set is 225. But the 225 number is not an outlier because it's not higher than that. Okay? So let's see how we do a box plot. We're going to use the stat plot button up here. So I'm going to do second stat plot. You pick a plot to use. I'm going to use plot 1. I'm going to hit enter and turn it on. If it had been off like this, you would put your cursor on and hit it on. And what I want to use is, I click down arrow to go to the types. There's 6 types. I'm just going to use the standard box plot, which is type 5. And the data that I want to use is in list 4. And again, you just use these second functions above the numbers to put the list in. Frequency is 1. Again, if I was doing a box plot for a frequency distribution, I would have to tell it which list had my frequencies in it. To see the box plot, we have to do a zoom down to option 9, which is zoom stat. And there's our box plot. If you want to see what the values are, you can hit the trace button and scroll back and forth. You see our min is 4.5, Q1 35, median 68, Q3 113, and the max 225. I want to point out again that box plots are plotted against a uniform scale. You don't draw your x-axis and then label your Q1, median, Q3, and then draw your box plot. No, you draw your x-axis, you label it in uniform 10, 20, 30, 40, 50 slices. Then you go above and locate where on that number line your Q1, median, Q3, your max, and your min should be. Okay? Let's show this is the standard, or what the book calls a skeletal box plot. There's another type of box plot that the calculator can do, and I'm going to go to back to stat plot again. So I'm going to do second stat plot, and again pick plot number 1. And if you go down to the type, you notice that there's another type here that kind of looks like a box plot with little dots on it, and that's basically the modified box plot. What it'll do is if there are outliers, it'll show them with a mark, and you can pick which mark you want to use. It adds this. I can show them with this little square, a plus sign, or a dot. I'm just going to leave it there. I'm going to do a zoom to zoom stat again, and I get the same screen. There aren't any outliers in this data set, so I don't see any of those extra markers on there. Let's go in and change our data set so that we have an outlier. We know that the upper fence is 230. So if I go down to list 4 and scroll down to the last entry, let's change that last entry to make it 235. Let's say the highest budget movie was 235. I don't know, what is it, Star Wars 7 or something like that they spent $235 million on. And let's go back and do the stat plot. I don't have to change anything. I've already got my stat plot set up to do a box plot for list 4. All I really need to do is a zoom to zoom stat. And instead of scrolling down to option 9, you can always just hit the entry button. Notice I've now got an outlier. Okay, if I do trace, I'll go back to the left. My minimum is the same. My Q1 is the same. My median is the same. My Q3 is the same. And notice that my maximum is now 200. It's the second highest value in the list instead of the highest value, because the highest value is an outlier. And then the max is 235, which is now my outlier. So that's how you would do a modified box plot. And in fact, that's the easiest way with the calculator to check for outliers. It's a lot easier than calculating those fences like we did earlier in the demonstration. Just let the calculator do it. There is one thing I want to caution you. Let's get out of this. And let's recall our one variable stats entry. And I'm just doing second entry until I get back to my one variable stats for L4. One thing I want to caution you. The calculator uses a slightly different formula for calculating quartiles and percentiles than what the book does. The minimum and the medium and the maximum, the way the calculator does it is exactly the way the book says. Q1 and Q3, the way the calculator does it is slightly different than the way the book does it. In fact, the way the calculator does it is the same way that Microsoft Excel does it. Percentiles are one of these things where there's not 100% agreement on exactly which way you do it. And the book has one way of doing it. The calculator has a slightly different way of doing it. So the point is that for problems, some problems when you run them on your calculator, you might get a slightly different value for Q1 and Q3 than the book might show. Don't worry about it. Either one of them are okay. It's just, don't be surprised sometimes if you see Q1 and Q3 are slightly different, which means your upper and lower fences might be slightly different because they're based on Q1 and Q3. So that's the demonstration for Chapter 3 for doing all the calculations.